Alright, today we'll be talking about geometric sequence and series. Okay, sequence is pretty straight up simple. Once again, review of Algebra 2. Here's the actual formula. Do not forget the n minus 1 right there. Okay, now geometric series, we're only going to talk about the finite version. I know in Algebra 2 you guys have talked about the actual infinite, but we'll talk about that at a later time because that leads into the next section, which is so important to the series and sequence chapter for pre-calculus. It's getting ready for higher level math. Okay, now this is cool because no matter what r is, this is actually going to be the sum for it. Okay, now if you wanted to find r, once again, take the second term and divide it by the first, or the third divided by the second, or the fourth divided by the third. It's totally up to you. Okay, that is the common ratio and how it works right there. Now, geometric means, the geometric mean is how we would work with this type of problem right here. Okay, where we have three unknown numbers between 3 and 48, but we do know that this is geometric sequence. Okay, so to find this middle number, what you're going to do is you're going to actually do the square root of 3 times 48. Okay, and when you get that answer, you should be able to see it, and you're like going, oh, that's really easy. But it's one of the most underused forms available. Okay, alright, and so that number actually turns out to be 12. Okay, and to get each subsequent number in between, once again, you still do the square root, and in this one it would be 3 times 12. Okay, that should be 6. And then this one right here, it should be 12 times 48. And this one should be the square root of 12 times 48, which will actually be just 24. Okay. Alright, so when we are working with geometric means, make sure you're multiplying it, but then you square root. In arithmetic means we added and then divided by 2, but in this one we square root. Okay. Alright, so that's it for just working with it. Let's work on finding variables. Okay, so find the 15th term of this sequence. Okay, so what we do is we set it up as a sub 15 is going to be equal to 12 times the common ratio. Oh, forgot to do it real fast, but it is actually going to turn into 1/3, and then we're going to raise that to the 14th power because it's going to be 15 minus 1, and that is actually going to be a really nasty number. So 12 times 1/3. Make sure you're using 1/3 and not 0.333 because you want to round up to the nearest. You want to get no decimals used whatsoever. So this is going to be 0.234525089-ish. And this is going to be an approximation right here because of just how it works. But if we use exact numbers to get that approximation, then we're okay. There we go. Okay. Alright, and that's the 15th term of this sequence. This is geometric. Okay, now find r. Well, let's go ahead and find the first term if the 9th term is 1,835,008 and r is 4. Okay, so we set it up 1,835,008. Okay, equals the first term, so that's going to be a sub 1. And you're going to times that by the common ratio, which is 4 to the 8th power. Okay, so as you can see, this is turning into a really simple problem. Oh, let me put the first term right there so we understand what we're looking for. Okay, 4 to the 8th. And so just rewriting this real fast, 1,835,008 equals a sub 1 times 65,536. Okay, and what we're going to do is just divide. So that one's pretty simple. 1,835,008 divided by 65536. And this one's going to be nice and neat. It's going to be 28 is a sub 1. So really cool stuff to actually work with right there. Alright. Alright, now finding the r if the first term is negative 20 and the sixth term is this. This one's going to be a little bit trickier, okay? So the sixth term, we're going to set up 0.625 equals negative 20 times r to the fifth power. Okay, because remember we do one less. Okay, so we're going to divide both sides by negative 20 first. And yes, we are dividing a so this will be 0.3125 equals r to the fifth. And you already have the tools to actually do this, so you're going to do the fifth root. Okay, now a lot of your calculators might not have that, so you might need to raise it to the 1/5 power. So please understand, fifth root is equal to power of 1/5. Just understand that. And when we actually do it, oops, let's get our answer. I like using the rationals and everything, so r is actually going to be 0.5. Okay, so in this one you're just going to do the reciprocal of the actual power. Now finding n is going to be a whole nother problem because you're going to actually have to use some logs to do this. Okay, so finding n, if the first number, I meant to say if, not is, if the first number is 9 and the nth term is 288 and the common ratio is 2. Okay. Alright, so you could do this. You could literally just put in that formula and just calculate it until you actually get it, and then you can count how many times you did it. But you could actually solve this one. 9 times 2 to the n minus 1. Now in this one, please do not go 9 times 2 and get 18 and then divide both sides. You're going to divide both sides by 9. So 288 divided by 9. That's going to be 32 equals 2 to the n minus 1. Okay. Now you could do this one of two ways. You could do the common base. In other words, if you notice 32 and 2, I can both reduce that, or you can do the log. It's up to you how you want to do it. So I'm going to do the common base. All right, 32 is actually going to be, let me see, 2, 4, 8, 16, 32. It's going to be 2 to the fifth. Okay, so what I'm going to do is I'm going to replace that with 2 to the fifth equals 2 to the n minus 1. Okay, now if you notice, both bases are the same, so both exponents have to be the same. So 5 equals n minus 1, and thus 6 must be equal to n. So the number of terms is actually 6. If you like to do logs, you can do this way. You can do, that's using common base. Okay, if you like logs, okay, you could do log of 32. All right, now equals. Now this one, when we do the log, we can bring down the n minus 1 and times it by the log of 2. Okay, and what we would do is divide both sides, and when you go to your calculator, make sure you put log of 32 in parentheses, so log of 32, and then divide it by log of 2, and you'll be surprised to find that you'll actually get 5 that way. Now if you did the log of 32 and divided by the log of 2 and you found that to be a really weird number, just leave it as the log of 32 divided by the log of 2 until the very end. And this would be equal 5 equals n minus 1, which would be n equals 6. Okay, and as you can see, the only tough one that really comes about is when you have to find n in a geometric sequence and just work with it. Okay. All right, now a finite series. Just remember the first term. I forgot to write that in there. There we go. The first term times 1 minus. This one you're not going to have the n minus 1, but just be very careful that you're plugging it in. Okay. And a lot of you guys are probably going, well, if our ratio is above 1 and we're raising it to a really large power and then subtracting that from 1, won't we get a negative number up here? Yes. But also on the bottom, you're dividing by a negative number, so that will also help cancel out the negative, okay? All right. It's also okay to get a negative sum. Just so you know, it's when you add up a whole bunch of negative numbers. But just so you understand, when you're working with this, it's going to be real easy. Oh, and, sorry, back on this one. If you were doing an even root, you would need to understand that you would be getting a plus or minus version of the answer. And if you're getting a plus or minus version of the answer, that would fulfill both situations that it might come up to be. But because we did an odd root, we just take it as is. Okay? So please understand, when you're working on this stuff, if you're doing an even root, you need to have your answer in plus or minus. Okay? All right. That's it for working with this. I will talk to you guys later. Bye.